Hello, and welcome to this tutorial on CTC's MEP Productivity Pack for Revit. In this video, we will look in depth at the linear adjustable universal light fixture family. Many types of light fixtures are specified by length of run rather than by quantity. Fixtures commonly specified by length include tape lights, slat lights, and linear pendants. The most common way these fixtures are modeled in Revit is to either place an array of multiple instances of the fixture or create multiple types in each length needed within the project. These methods are cumbersome to implement. The EPP has a solution for this problem, the linear adjustable universal light fixture. Let's take a look at it now. Here is an instance of the linear adjustable fixture in plan and in 3D. You can see here that this type is a simple rectangular extrusion, and its symbol in plan view is a dashed line. Let's open its type properties to see what's inside. This type is type AL1, which is a representation of the Juno Flex Connect asymmetrical tape light. There are 3 pre-configured types in the sample project, and a couple of types specifically for the symbol legend. Let's start our tour in dimensions. The dimensions options for this fixture are pretty simple, width and height. These entered here are the actual dimensions of this Juno fixture. If we change them, we can see the dimensions of the fixture change. Notice that length is missing. In fact, you can see it over here in instance properties. We'll get to that later. Let's undo that dimension change and go back to type properties. Most of the rest of the parameters and dimensions are common to many universal lighting fixtures, recess and suspension settings. See the user manual and other tutorial videos on those settings. The one unique parameter here is max stem cord spacing. Let's come back and look at that one later. For now, let's scroll up to graphics. There are 2 symbol options to choose from, a line and a rectangle. The line symbol is what's currently selected. This line style is controlled in Object Styles, Detail Items, Linear Light Fixture. If we change the line symbol to a rectangle symbol, we see that it changes to a rectangular symbol, and the symbol's width is controlled by the parameter symbol width. Note also that the symbol width parameter controls the width of the critical and life safety hatches, even if the fixture is set to be a line symbol. So if we change this back to line and go click critical, the critical hatch will appear. The width of this hatch is controlled by the parameter symbol width. Now let's look at fixture length. The length of the fixture is controlled on a per instance basis. The controlling parameter is here, fixture length, under dimensions. Right now it's 4 foot, but we can change it manually to 3 foot or 2 foot. Perhaps an easier way to adjust the fixture, especially if you're trying to adjust its length to fit a particular space, such as a cove in a ceiling, is to drag it in plan. If we select it, notice that there is a grip here at one end. If we hover over the grip, a tooltip appears with some information, and at the end here we see fixture length. This indicates that dragging this grip will change the parameter fixture length. Click and drag, and the fixture changes length. As the fixture changes length, notice that the fixture length parameter in the Properties palette changes. The grip will snap to objects as you drag. Notice the ceiling grid lines turn blue as I hover over them. And you can also use the Align tool. So here I can align and select the reference, and then select the end of the fixture. The fixture stretches to the reference. Note that Align only stretches the fixture from the end with the grip. If I align from the other end, it doesn't stretch, but rather moves the fixture. Next, let's take a look at the light source. Let's turn it on in Visibility Graphics, and let's align this view to the top so we can see well. Now I'll stretch the fixture, and notice that the light source is repeating. The light source is controlled via type properties. The source definition is controlled the same as all other universal lighting families. This family has 2 unique parameters, light source spacing and rotate light source 90 degrees. Light source spacing controls the spacing of the light source. It's currently set at 1 foot. We can change it to 2 feet, and we see that the spacing of the sources and their quantity adjust appropriately. For these types of fixtures, when you download an IES file from the manufacturer, it is for a specified length. 1 foot is typical of tape light. Enter that length here for the source to be repeated over the length of the fixture as required. The parameter rotate light source 90 degrees also does just what it says. It rotates the light source 90 degrees. This parameter is a replacement for the light source rotation parameter used in other families. Limitations within Revit prevent that parameter from being used in this family. Now let's take a look at suspension settings. Let's change this fixture to type AL3, which is a suspended fixture, and orient the view so we can see it better. Notice that this fixture has stems. The stems are repeated in a similar manner that the light sources are repeated. As we stretch the fixture, the stems automatically adjust. The spacing is controlled with the type parameter max stem chord spacing. If we change this value, the stem spacing follows. Now let's take a look at power. Power for linear fixtures such as these is typically reported by manufacturers in watts per length. As the fixture changes length, its total power consumption changes. Back in Type Properties, under Electrical Loads, we find the parameter watts per length. This length is the unit length, which is set in project settings. In the US, this would be watts per foot. This fixture's power draw is 3.85 watts per foot. Apparent load, here in the Type Properties, is disabled because it is a built-in Revit parameter that cannot be edited. Instead, we're using apparent power, an instance parameter, and you can also see here watts and current. As the fixture changes length, its load changes accordingly, and this load is reported to the panel board. This fixture is already circuited, so if we open the panel board, we can see the load on the panel board changing as the fixture changes length. Before we go, let's take a quick look at how this fixture is used in the sample project and how the fixture is scheduled in the lighting fixture schedule. In the sample project, we see this tape light, type AL2, is wrapped around the lobby. There are two instances of the fixture on this level. One is here, stretched from here to here. We can grab its grip and change its length and align it back to where it's supposed to be. Type AL1 is wrapped around the stair tower, two instances, and type AL3, a suspended linear fixture, is providing the primary illumination for the lobby. These fixtures appear in the fixture schedule just as any other lighting fixture, except total watts are not usually reported. Instead, watts per foot are reported. If there happens to be only one instance of the type in the project, or if all instances in the project are the exact same length, the watts parameter would populate in the schedule. Now you know how to use the MEP Productivity Pack's universal fixture content to model nearly any linear light fixture. Thanks for watching, and be sure to check out our other tutorial videos linked in the user manual.